A very good morning, students. So this is the next video, that is the continuation video on the chapter current electricity. So in this video we will be learning different topics. First topic which I will go through, that is color code of resistors. We know conductors have resistance within it. So whenever a current is passing through a conductor, it faces an opposition, that is the obstruction to the flow of current. This generates resistance. So actually what is the concept of resistance is that, you see, whenever a current is passing through any conductor, the electrons, they collide with the positive ions. These positive ions in the metal or in the conductor does not allow the current to flow freely. So likewise, the collision increases and the electrons does not flow freely from one terminal to the other, and this generates the resistance, that is the opposition, right? So you see, by looking the conductor, by looking its strips, that is the ring strips, we can say that how much resistance it has. So here in this topic we will learn, if I have one conductor and the conductors has different colors within it, that is the color code. So by looking the color code, how we will understand what is the resistance, what is the magnitude of resistance, or what is the tolerance of that conductor, right? So let's start our today's topic. A color code is used to indicate the value of the resistance and its percentage reliability or tolerance. Just now I told you, by looking the conductor you can say how much resistance it has or how much tolerance it can have. Like the resistor has a set of concentric rings or bands of different color on it. You see, I have considered one conductor here. It has 4 rings, right? First one is red in color, second one is red in color, third one is orange, and fourth one is gold. So these red, orange, gold, they have their respective color that is fixed. So we have to remember that those colors. If you don't remember those colors, then you are unable to find the magnitude as well as tolerance. So first two ring, you see, first two ring indicates the first two significant figure. That means the value of red is 2. Again, red is 2, right? And third strip shows the value of 0. That means what is the power? Like orange has 10 to the power 3. So these 3 rings we have got first two digit and the 10 to the power number. This is the magnitude, right? And the fourth ring indicates the tolerance. So tolerance can be in golden color, it can be silver in color, right? Or there can be no strips also. So we will be learning what are those values and how to remember those values, right? So this is very important. So on the screen you can see the color code of resistors, right? So color, we have black, brown, red, orange, yellow, gate, or that is green, blue, white, grey, white, gold, silver, no color, right? So these are the color and these are the numbers. So we need to remember the numbers. Just we will match, you see. So the resistors which we had, that has first color was red. So let us see red. Red is given as 2. So I marked here 2, right? Similarly, next color is also red, that is 2. So next one is also 2. Third, we have orange. So what is the orange? 3. That means this is 10 to the power 3, right? Now you see 3 rings over. Now fourth ring we have gold in color. So for gold we don't have a color multiply here. We have a tolerance, that is 5%. That is plus minus 5%. This tolerance indicates that what is the quality of the conductors. If it is plus minus 5%, that means only 5% is more or 5% less. It has you see reliability, that is the tolerance. It indicates whether it is good or bad. That is 5% good or 5% bad, right? So and also it depends on the silver, that is 10%, and no color. If we don't have the fourth ring, fourth strip, then we will consider it to be as no color, and in that case we have to write here 20%. Okay, if fourth ring is missing here, then we will not write 5% here, we will write here 20%. This is how we have to mark color. Now the main thing is that how to remember those color, right? We have to remember those color and respective number. So I will give one mnemonic. So by using that one we can remember this color, right? So you see, I have wrote here one mnemonic. So we can say black brown rod of your gate becomes very good when given silver or no color, right? So black brown rod of your gate becomes very good when given silver or no color. That means you see, black means here black, brown means here brown, rod means the R, that is the first letter R, it stands for red, of OF, that is O stands for orange, your, that is Y stands for yellow, GATE, gate, G stands for green, becomes blue, V for violet, and G for grey. So remember here we have a gate and wood, that both are starting with G. So first G, that is for green, and second that is for grey, right? When, that is white, given, that is gold, and silver, that is silver and no color as it is, right? So up to white we will be placing here this number, that means 10 to the power 9 or 9, okay, and rest, that is gold, silver and no color, we will be placing as tolerance. So this is how we are going to mark the color coding. Suppose randomly I have marked one color. Let us consider this is blue, this is green, okay, and this is red, and this is silver, okay. So we have to mark this color coding. So what is blue in color? Blue we will see, that is blue is 6, that is first will be 6. Next is green. So for green we have 5, that is 65 into, for red we have 10 to the power 2 plus minus, and silver will have 10%, right? So this is our answer. So you place a ohm, that means 6500 plus minus 10% is the value of this conductor, right? So this is how we are going to find. Now converse is also true. If I give you any number, like for example, if I say you 13 into 10 to the power 5 plus minus 10%, so write its color or draw the color code. So we can draw in the converse way also. First we have 1, for 1 we have brown, so first we will draw the conductor, right? 1 2 3 4. So first one is 1, that should be in brown in color, then first one is brown. Second we have 3, that means 3 stands for orange, that means second we have orange here, right? And third one we have 5, for 5 we have here green, so this will be green, right? And 10% we have 10% for silver, right? So this is how we are going to color code, right? This is a very important topic. First we need to see the color of the strips, then we have to mark the number. So first two ring gives the two significant figure, so that one we will get from the number, and third one we will get from the multiplier, and fourth ring we will be getting from tolerance. So next topic we have combination of resistors. Next topic we have combination of resistors. Now resistors can be connected in series or in parallel. This one we have already learned in our junior classes, right? Now if the resistors are connected in series, then current flowing through the branch will remain same. Now if the same resistors, if they are connected in parallel, voltage will remain same. So this one we have learned in our previous classes. So let's see what will be the circuit diagram of series, that is series connection. Now if I say series, two resistances that is R1 and R2, right? These two resistances are connected in series. Now the same current will be passing here, that means I will be same and voltage will be different, right? That means it will have different potential drop. But similarly, if the resistances are connected in parallel, here you see R1, R2 and R3. So this resistance, you can add one more resistance here, or you can keep it as 2 only, right? So R1, R2 and R3. So first one is series resistance, series combination, and next one is what? Parallel combination. So this is parallel and this is series. So what will be the equivalent resistance here? That is R1 plus R2 plus R3, right? But in parallel combination we have 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. But listen, in the previous video we have learned the series combination of capacitors and parallel combination of capacitors. That is a totally different from these formulas. Like you see, if I consider the capacitors to be connected in series, so if the capacitors are connected in series, so C equivalent was 1 by C1 plus 1 by C2 plus 1 by C3. If I consider this one is C1, C2 and C3, right? But the same capacitors, if they are connected in parallel, you see C1, C2 and C3, then C equivalent would have been C1 plus C2 plus C3, right? Remember this one, when resistances are connected in series, so R1 plus R2 plus R3. But when capacitors are connected in parallel, that time C1 plus C2 plus C3. Similarly, when resistances are connected in parallel, that is 1 by R1 plus 1 by R2 plus 1 by R3. But when capacitors are connected in series, then we will be having in reciprocals. So you will be remembering only one, like you remember only the resistance, this because this one you have learned in the previous classes. So you remember the resistance. Now resistance which are in series will be for capacitors which are in parallel. Similarly, resistance which are in parallel will be same as the formula of capacitors connected in series, right? So this is how we will remember the formulas and the expression. So based upon combination of resistors, there is one question you see. Two resistors of resistances 4 and 5 ohm. So let us consider here resistance 1 is 4 ohm and resistance 2, that is 5 ohm, right? Respectively are put in the parallel and 3 such are put in series. What is the resistance of the whole circuit? So here in the question it is said that there are two resistances, that is 4 ohm and 5 ohm. They are connected in parallel, right? And this parallel combination, this circuit is being repeated 3 times. So what is the resistance of the whole circuit? So let's draw the circuit first. So here two resistances are connected, 4 ohm and 5 ohm, that is in parallel, and similarly right, similarly 4 ohm, 5 ohm, here. So first we will find the resistances, that means resistance which are connected in parallel, that is 1 by 4 plus 1 by 5. So LCM is 20 here, that is 5 plus 4, or R2 will be 20 by 9 if we take the reciprocal, right? So one section we have 20 by 9 ohm. So what will be the 3 reaction? That means R equivalent will be 3 into RP. That means 3 into 20 by 9, right? 3 3 is 9, that is 20 by 3 ohm. So this is our answer. So this is how we are going to solve for the questions based on combination of resistors. So the next question you can see in the screen, there is one circuit diagram. So we need to find the total resistance between A and B, right? So 3 resistances are there and here it is shortened. Okay, you see how to understand whether the resistances are connected in series or parallel. Suppose we don't have these 2 terminal, right? So from this we can understand that same current is flowing through the each and every resistor, right? So if each and every resistor is getting the same amount of current, then we will say that these resistors are connected in series. But in case if I place here 1, right, you see the current is flowing here and one branch of current is passing here and same current is passing through these two resistors. Then we will say that these two resistors are connected in series and this combination is parallel with this combination, right? So because same current is passing through this 5 ohm and 10 ohm, and whatever will be the answer, combination of these two will be in parallel with the third one. So but in our question, the question which we had, this was our question, right? Now you see, first current is coming here, different branch of current, again different current is passing here, again as soon as the current passed here, it has flown to this one, so again different current is passing here. So from this diagram it is clear that these three resistors are connected in parallel, because different resistors are getting different amount of current, not a same current, right? The current is getting changed, okay, or divided, you say, right? So if I consider this one as R1, R2 and R3, we will say 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. Here R1, R2, R3, R1, R2 and R3 are in parallel, right? As they are in parallel, so 1 by 5 plus 1 by 10 plus 1 by 5. LCM is 10. So 5 to the 10, 1 plus 2, therefore 5 by 10. Or R equivalent will be 10 by 5. That is 2 ohm, right? So what is the total equivalent resistance of this combination? That is 2 ohm. So based on combination of resistors, so we have one question here, you see. Two 1500 ohm resistances joined in series are in parallel with three 500 ohm resistances in series. A single resistance of 6000 ohm is placed in parallel to the first two series combination. Find the total resistance of the network. You see, two resistances are there. These are connected in series, and the three resistances, they are connected in series, and these three resistances all are in parallel with the first two, and 6000 ohm is also parallel with the other branches, right? So we need to calculate the total resistances of this combination. So as these are in series, so we will be getting 1 by 1500 plus 1 by 1500, or you see these are in series, you see first, that means first we have to add 1500 plus 1500, we will get in series answer. Similarly here, this all we have to add, we will get in series, and 6000, that means here 3000, 1 by 3000 plus 1 by, you see, 1500, and here 6000, right? So this all will be in series. So you see it is being solved here also. So just for understanding, I have shown you this one. So we have 3 here, so 1 by 3000, because 2 1500 were there, and 3 500 is there, that means 1 by 1500, and 1 by 6000, so 7 by 6000, and the equivalent resistance will be 6000 by 7, right? So total answer is 857.14. Similarly, we have this next branch, you see, next combination. These two, that is R1 and R0, they are in series, and their answer will be in parallel with the third, that is R1, and R1 and this combination and R1 will be parallel, right? So I repeat, first these two are in series, these two resistance are in series, their answer is in parallel with this, and whatever answer we are getting here, that will be in series with R1. So this is how we are going to solve this type of circuit, right? So we may have this type of circuits also. You see, it is a complex circuit. So first 3 and 3, they are in series, their answers in parallel with 6 ohm, and whatever answer we are getting here, that is in series with again 3 ohm. Again this answers in parallel with 6 ohm, it is in series with 3 ohm. Now their answers in parallel with 6 ohm, and last they are in series, right? So this is how we are going to solve. So this all last answer which we will have, that will be in parallel with the other two. Okay, so last answer is 2 ohm. So you will be trying this question at home. So you need to calculate this question also. Calculate the total resistance of the network. So answer is 7 ohm. Next question, calculate the equivalent resistance between A and B. So two circuit diagrams are given. So you will be solving for this also. So one you have 9.6 ohm and 40 by 3 ohm. Next question, you will try this one. Question number 52, calculate the value of R if the net resistance between A and B is 1 ohm. So if the total resistance of this circuit is 1 ohm, then what is the value of R? That is small r. Answer is 3 ohm. This question also you will be solving. Question number 73. A network of resistance is connected to a 16 volt battery with internal resistance of 1 ohm. Obtain the current in each resistor. So we have to find the current in each resistor and also obtain the voltage drop, that is VAB, VVC and VCD, right? That is figure number 2.27. So answers are also given here. So this question also you will try at home. For today only this much. So few questions I will be giving example questions like these solved questions. So that one you need to write it in your copy. By looking the solution you will understand just the formulas which we have discussed. Okay, try to remember the formula and solve those questions. Thank you.